guys, how have you been? It's been a while. Yet again is Access Points Academy video lecture series. And in our video series today, we want to look at this GCSE question on energy changes or changes in energy. And what does the question? What does the first question says? The first question says, and I read: a student uses an electric motor to lift a load. All right, as we can see, this is the load. This is the electric motor. The student uses it to lift this load up this length. We have the spring. This is the pulley system. And the question continues. In the motor, the electrical energy is transferred into other types of energy. Some of this energy is useful and the rest of the energy is wasted. Now, name the useful energy output from the electric motor. So now what is the energy output from the electric motor, which is very useful. Now the output energy from the electric motor, which is useful, is kinetic. Okay, kinetic energy. All right, it will also be accepted if we say gravitational potential energy. Why? Because the object has actually been lifted above a height. But because there is motion of the object, the load, so we say it is kinetic. Accepted also is gravitational potential energy. Now, what does the next question says? The next question says, what eventually happens to the wasted energy? Right, good. Now, the wasted energy are actually dissipated to the surrounding. So you can just write that wasted energy is dissipated to the surroundings. All right, so now what does the next question says? The next question says the graph shows the input energy the motor needs to lift different loads by 1 meter. So we have a graph, and what is the graph? All right, here is the graph. Okay, the graph actually shows this axis shows input energy needed to lift the load by 1 meter in joules, and this is the load in meters. Now, what can you conclude from the graph about the relationship between the load lifted and the input energy? All right, now from here, from this curve, we can clearly see that as the load increases in size, in quantity, then there is also an increase in the energy input or the input energy. So we can just write the first point that as the size of the load increase, there is also an increase in the input energy. Okay, also there was a small increase when the load is between 0 Newton, 0 Newton to 2 Newton. All right, so that answers that. Now quick one to the next question. Now Now in the next question we have, a shop uses escalators to lift customers to different floor levels. The escalator uses electric motors. When the shop is not busy, some escalators are turned off. A sign tells the customer that the escalator are turned off to save energy. Alright, now the question proceeds. Each escalator has one motor with an average power of 4,000 watts. The motor is turned on for an average of 8 hours each day, 6 days each week. Electricity costs 15 pence per kilowatt hour. Calculate the cost of electricity used in an average week to run one escalator. Show clearly how you work out your answer. Alright, we have been given the power, which is 4,000 watts. Now this we need to convert to kilowatt, which is equivalent to 4 kilowatt. Okay, then we know that energy is the product of power and time. Okay, so therefore the power is 4 kilowatt hour. You multiply that by time, that is 8 hours in 6 days. So multiply by 8, multiply by